hibernate project to actually take hibernate in JPA and layer that on top of the document still on the back end. So it gives us a familiar looking front end, but a little bit different than the back end. So Amazon has Dynamo and S3. There's actually a little bit of Dynamo paper out there as well. It talks a lot about the original implementation. It's very good for you. React is very tunable on the CAP side. They have very strong distributed storage model. And it actually has a built-in MapReduce. React is one of several that are written in Erlang. So most of these products tend to be written in either Erlang or Java. HouseDB gives us full ASIC compliance for REST API. MongoDB gives us strong indexing and query support. So you notice that these different products kind of fill a particular niche depending on what it needs are, and one may fill it better than others. Baltimore, which is Java-based and has pluggable serialization. I believe, somebody correct me if I'm wrong, I believe Baltimore is very good. And MySQL. So MySQL is a little bit of a document here, but there's a number of companies that are using it in kind of this way. Facebook kind of knows it. They're very big in nosql, if you're familiar with that. And familiar with Facebook, there's at least one open source project where we're taking MySQL and stripping it down into a very purpose-built document store. And in this case, what you're doing is you're denormalizing the data. You basically just do the key access, you're killing your indexes, all your tables, your relationships, all your relational data, and just boiling it down to just a core so that you can get documents in and out as fast as you possibly can. So memory stores, these are really, really similar. The data models tend to be almost exactly the same. And again, when you look on the web, you'll find out that these are usually put together as the same. But the purposes tend to be quite a bit different. So the document stores tend to have a very solid on-disk representation. They want to store all the indexes in memory, but the data can live on disk just fine. It kind of focuses there. Memory stores tend to be used more for high-speed caching types of operations, where you need either a local or distributed cache. You want to be able to put your information in there and get it out as fast as you can. Partitioning can be a little bit tougher in this space, but there's a lot of products that can do partitioning really well. Several of these do have an on-disk representation. Usually it's basically a pen-only kind of a mode where it's kind of keeping it for backup in case that node goes down, it can come back up, and your cache has some information available, especially if you've got multi-gigabyte caches sitting in front of the database. You can have problems where you're bringing up, where a cache goes down, you bring it back up, and you're killing your database because it's trying to cache everything back out. So some of these products should look really familiar. One interesting one is Couchbase, which is CouchDB, and Membase are kind of combining forces together to make a really nice hybrid product. Memcached, which we use a lot of times we use Memcached, and local mode also has a distributed mode. Coherence, which is a commercial Oracle product, has very strong local and distributed support, very active development. Redis is actually quite interesting in this space. They build themselves more as a data structure server. So instead of just storing hashes, they're going to store sets and list sorted sets and stuff like this, so you can do different kind of set operations. You can do some more complicated types of manipulations with your data there. They also support really high-speed counters. So if you need counters that you can update 100,000 or 500,000 times a second, Redis has really good support for that, and really nice incremental front. Tokyo or Kyoto Cabinet is a dispatch map implementation. Infinispan, which is a very hot project, they implemented JSR 107, which is kind of a red spec. Mostly red spec. There's a new spec that kind of comes out that it generally picks up where JSR 107 came from, JSR 107.com. And then Scalera, which is Erlang implementation, which they focus very much on strong consistency. So graph for triple stores, this is going to be a little bit different here. In that you have to think in terms of nodes and edges. there's not really a schema. You have nodes and you have edges. And they're put together in what's called triples. You have a subject, you have an object, in the middle you have a predicate that defines the relationship between those two things, those two objects. And a lot of times the relationships can be bi-directional, and you can hook all these nodes together, these relationships in very complicated ways. So for example, this is how Facebook knows that your friends, what friends you have in common with some other person, or, your high school buddy or whatever, it's got online. It's how it builds and manages all those kinds of relationships. So if you have that kind of a need, this is stellar. It works really well. Doesn't work very well as a general purpose data store. Again, schemaless, nodes and edges, they generally support very fast set kinds of operations, unions and all kinds of stuff like that. But if you want to read more about some of the theory behind it, if you go to the W3C site, they've got a lot of information about this because it comes out of the semantic web area. So some of the products in this space, we have Neo4j and Graph 12, which is two of the more mature products that are in this space. So Neo4j gives you full Elastic transactions, and they also have an object-oriented API. Graph gives you Sparkle referencing implementation of Sparkle. Neo4j has Sparkle too as well. But it's one of these SQL-style languages that are available, but it's geared for this particular space. So it's going to feel a little bit similar, but it's going to be different in one way. Big data, which is actually a generic term editing for this particular language, is dynamic sharding, rooted dynamic sharding. Trinity is a Microsoft research project, so it's one of the few products here that not only runs on a Microsoft platform, but very Microsoft specific. And it still is a research project, but works actually really very, very interesting. Infinite Graph is distributed across platform, a lot of good support there. BlockDB is kind of cool. This was another one of these company-derived products. Twitter in this case. So they have a need to do really super ultra-fast set operations against really large sets. So if you're trying to tweet somebody, they've got millions of followers, and somebody else has millions of followers. It wants to be able to find those unions and different set style operations, so it can be as efficient at sending out those tweets as possible. And so what they did is they wrote their own implementation called BlockDB and open source, so it's available for everyone to use. It's not quite as good in the general sense as some of the other ones, but it has a really, really good purpose there. And InfoGrid gives an object-based API along with the REST API, so you can sit down and command line with Perl and kind of play with the state if you want to test it out. So this slide I added just a few days ago, actually. I'm calling it interesting integration. So one of the real problems with a lot of products in this space is there's not a lot of good indexing or searching support, stuff like that. So if you have a document store and you don't know the key, you can't get your value. So so the problem is, how do I find keys in the general sense if I don't know them? Some of them will allow you to get all the keys for a bucket, but if you've got millions of keys in that bucket, that doesn't help you out a whole lot there, right? So a lot of these products are actually taking Lucene, which we know now as at least one of our favorite search engines that we can integrate, but Lucene itself is really just an engine. It provides a ton of really cool features, projects that are around for a long time. There's a ton of support, there's a ton of development going on. And so two of the projects that kind of wrap this are Solar and Elasticsearch. Elasticsearch is a little bit product, but it gives you a JSON style look and feel in front of it with a REST API and a really interesting scalability model. Solar gives you a lot of the same kinds of things with some XML configuration abilities. It has a web interface and a scalability model with a lot of it. Solar is extremely popular because it solves some of the issues in using a Lucene core like distribution, right? Or having a scalable model behind it. React Search actually, React even in Erlang, they've taken the Lucene Java APIs and they're implementing them in the React core so that you get this search ability now where you